Hey everybody, welcome to the second installment of the Net DevOps webinar series. Today's topic is designing data center and campus networks for remote administration. If you missed the previous webinar, please visit events.arista.com/webinars to view that recording. And the next webinar in our series is going to be on May 7th, same time, same place.
Same bat channel.
Exactly.
Thank you, Whitney. And Fred, my partner in crime. So you're probably looking at this going, okay, let me get this straight. Net DevOps, automation, maturing my operating model, and then we dive right into how do you build a network for remote administration? Besides being slightly timely, which we'll talk about, the rationale is also that a couple weeks ago when we did our first Net DevOps webinar, Fred and I talked about a project that we were going to put together, and we got it done. And it's a simple program to allow you to back up configurations, which is a key part of the conversation we're going to have today. And so we've got it posted up to YouTube. We've got the GitHub repo up there, and we're going to make all of that available to all of you. So hopefully it becomes something that we can continue to build on iteratively and gives you some tools to better administer your operating environments, which is our overall goal. So let's dive into the topic today. And as we said, I'm Doug Gourlay. I'm joined by Fred, partner in crime, distinguished engineer, and overall amazing human. And the topic is business or operational continuity, remote management administration. But let's back that up for a second and talk about the flow we're going to have today. Okay, so rather than putting this slide at the end, like I was probably mandated to by some person in corporate marketing, Whitney, we wanted to put the Q&A up front. Chime in throughout this live session with questions you have. And we will do our absolute best using the Q&A manager to answer them live. I will try, if Fred does a really good job talking and taking over, which I really hope he does, he's good at, to also work them in contextually. Okay, so we're gonna do our best to jump in and answer these live throughout this process. If we don't get to it, that's cool. You saw our Twitter handles up there, you saw our emails up there. Feel free to reach out. We're thoroughly happy to have a conversation with any of you. And this topic, not only timely, but also what we found is there's just not a lot of domain expertise out there. And it's also a scenario where in data center networking, as a company and as a networking professional, I know I've spent, 15 of my last 25 years in this industry trying to find and create scalable design patterns that I can reuse. And in this domain, this how do I administer remotely, how do I build a management network and management fabric, which is different, we'll talk about the network observability, there is not a corpus of information that we could really go to. And so you'll see that coming up. And because of that lack of significant domain of knowledge, lack of a corpus of knowledge we could go to and pull, almost everything we're talking about today was like a new slide, new content. There was not a large basis to build on top of. So there's also gonna be a lot of unanswered questions. We know that. Please dive in, ask away. And if we need to pull off on a sidebar, or we need to follow up, or we need to get some of our systems engineering team with you to go through this, totally happy to do that. So I'm going to start, throw this out. Agenda slide, great, cool, skip. What are the principles we generally think about when we're designing and building data center networks? Let's start with that, and then we'll go into the specifics necessary around building management networks, requirements of that, challenges, and things we all just need to keep top of mind, and hopefully identify some best practices and some reusable design patterns that will help all of us do a better job in this. Like, first foremost, number one priority, and Fred, what do you think? I'm always just like, I put reliability top left for a reason, but would you concur? Like, I don't know anybody who's ever said, I'm going to build a network to be massively unreliable, unless you're like my former mobile carrier.
Right. I mean, that's kind of the end goal. Like, all of this stuff I think boils up to reliability, right? The reason we want to have all of these things in place is so that at the end of the day, that's the deliverable. We want a reliable network for people to run their applications on.
I think, and I hadn't thought of it that way, but you're right. Every one of these other aspects is a building block that fundamentally enables reliability as the core operating principle, right? Like the purpose of security, yes, protecting our data, protecting our applications, protecting our users from bad activity, protecting our critical infrastructure assets to preserve the reliability, the integrity, and the availability of those, to use the CIA triad, to preserve those for our network. Scale, right? You get too big, traditionally scale has often compromised reliability, and what the new cloud networking principles that have come in fundamentally around repeatable design patterns to enable scale has allowed us to have scale with reliability. I get that, makes a lot of sense to me. I lumped in and threw in there kind of a new addition, even against the conversation we had at the Tech Field Day earlier this year. Observability and automation as discrete topics that are increasingly necessary to achieve scale, to enable security, to enable us to prove that our network is truly reliable and defend ourselves against the usual, oh, the network's slow, it's the network's fault, the network's down, and let's blame the network first. Any final thoughts, comments on the principles that we think about when we're designing data center networks and how we apply those?
Yeah, I think one thing that I like to think about is a even broader context outside of the network, right? These are all principles that are going to apply across the board, whether it comes to application design, software design, best practices, how you deploy your servers, how you deploy your VMs. This stuff all matters across the board. So I think it's a core thing for us as network administrators and network operators to keep in mind, but it's also a broader conversation for kind of just the entire data center application development environment.
Yeah, and I've historically found when I'm going through design conversations with other technology and infrastructure professionals, baselining on, do we align with these principles?
Right.
If we can get alignment that we're going to apply these principles into the architecture, we get a lot less configuration drift, scope creep, or weirdness in the conversation, because we could always come back and go, we said we're going to design for reliability, ergo we have 2 tier 3 data center facilities 100 kilometers apart, reasonably geographically distributed, because that's the core principle. We said security, therefore we're doing a significant defense in-depth implementation, and a lot of the other things we're going to talk about will be applying into it. But if we can tie decisions back to principles, it's so much easier to drive organizational alignment, especially when you have people who do not share your level of domain expertise, who
Right.
You're trying to communicate an investment thesis, a design decision to go, these are the principles, let's agree. Now here's how the architecture reflects those and closes that loop back.
Yeah, exactly that. I think it's, if we can align on these principles overall, then it's easier to get people on the same train, right? So
yes.
You're not fighting the SecOps team, you're not fighting the platform team. Everybody's got the same goal in mind,
Yeah.
and we should all be helping each other culturally move things towards this common goal.
Why can't we all just get along?
Yeah.
And the method, start with the principles.
Yep,
That's
exactly.
how we can. Now, in remote data center operation, these are some of the challenges we found. Like, first off, when Fred and I did a search, when we started building this content set, it was a couple weeks ago, we said, well, this is going to be easy. Let's Google how to build a remote management network. And I didn't find jack. Let's Google management network design. Nothing. In fact, comically, I did find, and Fred found, like, there were 2 bodies of work. One was on bastion host and jump host architectures from the SANS Institute, an organization I've always held in very high regard, from 2001, 19 years ago. The other was an architecture that was built by a company I used to work for that I worked on in 2002. And I'm like, so the latest design principle, the latest architectures, the latest and greatest of how to design and build a management network for out-of-band management, remote management, whatever, of critical infrastructure assets was 18 years old. And this made our job hard. But you know what? It makes your job hard. And that's what we said, we got to figure this out, because the types of management infrastructure we're building around modern networks to have state streaming telemetry, to use GNMI, GNOI, gRPC, open config models, the size of the images we're pushing to these devices. Once as an industry, we made a shift to Linux. Compound all of this. We are not using X modem at 9600 bits per second in order to get, to load images over an out-of-band terminal server anymore. I'm not dealing with 56K serial lines to SSA, to a remotely terminal server into devices to recover them. A lot of the complexity of the system, the heavier weight of the protocols used in operations to monitor, to measure, mandate a different architecture than what we've historically done with a set of Livingston Portmaster 2ER20 sitting over there connected up, running serial lines to everything so I could just open up a TTY and get to it, right? That has changed. The other two factors, the threat landscape that we face as networking professionals whose job is to provide this highly reliable network, which means it needs to be reliable against my own screw-ups, against sometimes my carrier and service provider's mistakes, the poor facilities person who sometimes likes to unplug things for therapeutic reboots outside of, sometimes we call that emergency change control, but also an external threat actor, sometimes up to and including a nation state actor, depending on the type of business and operations we run, their job is to compromise the confidentiality, the integrity, or potentially the availability of the system we're running. And too often the weakest link in that system is our critical infrastructure, our networks themselves. I bluntly will say, I don't think most of us have done a great job in how we protect our networks from external threat actors. And the type of attacks maturity that we're seeing at Black Hat and DEF CON last year, there were some great presentations on this of how to execute in-band attacks to take over Ethernet switches and bypass every security control we've had. So the threat landscape's gotten worse. The operating environment is scarier. And what a bad person can do if they take over a device is compromise VLANs, compromise VXLANs, remove every access control list, bypass almost every security control we have, which compromises the reliability of the network.
Yeah, and I'd say, if you think about it over the past, it's scary to think that's almost 20 years now, but the criticality of the network, as we can see today, right, we're all having to work from home and work remotely and do all these things over the network. I think the business criticality of the network has just increased exponentially since, say, 2001 and 2002. And also the surface from accessing this through public cloud resources and hybrid cloud and all these other vectors that have opened up that are relatively new compared to when these documents were written, changes the landscape drastically too.
Absolutely, Fred. And then the lesson, I'm sure it was learned way before this, but the first time I personally experienced this was post 9/11, when the challenge, I went to New York in October and I was meeting with a lot of customers and people who built big, large financial services networks and operated them. And the consistent feedback I heard then, and I've seen it happen with Sandy, I've seen it happen with Katrina, I've seen it happen now, is that the biggest issue they face is not like my data center went offline. It's that I'm expected to maintain continuity of operations in an environment where I can't physically travel to my data center. I can't travel to my campus network. I can't travel to bounce the switch and upgrade it. And it's like, how do I provide continuity of operations when I physically can't get there? And that's what we're going to explore today. How do we do that? How do we design a network that enables that while balancing that with the threat landscape? How do I secure it? How do I audit that my security controls are functioning and working properly? How do I harden that environment and create a defense in depth strategy? How do I reduce that attack surface? How do I build a network that handles the type of bandwidth expectation that is necessary today to manage these complex environments with these more modern protocols that we're dealing with that are chattier, are heavier weight, because they produce telemetry that we now depend on. You see, I should have made these slides as a circle. This should be one of those, like, snake biting its own tail circles, like from Conan the Barbarian. When in doubt, in any geek presentation, throw XKCD and Conan jokes. It works every time.
Conan probably from the same era that those documents are written.
Ouch. I loved Conan dude. The Destroyer wasn't that good. The Barbarian was an outstanding movie. I'm going to rewatch that. Well, mostly because of the dialogue. Yes. It's almost as good as me and you chatting. In the same vein.
If only we could be so succinct as Arnold was in this movie.
Yes, I'm going to bring my broadsword to the conversation next time. All right. I'm just going to throw a few terms that to base, and also say, what are we talking about and what are we not talking about? At Arista, we talk about cloud networks a lot. We did a lot of work with large cloud providers. We learned a lot of architectural principles there about how they're designing to build at scale. Hopefully that was a cyclical thing where we improved product and they improved operations and vice versa. We built a universal cloud network architecture that is designed for the production network, right? It's designed for the apps and the data connecting to the users and consumers and so on. We thought about a lot, how do we build management into it? But I think this is the first time we're taking a discrete focus on the management network as a unique and sometimes standalone entity. With our acquisition of Big Switch and our previous DANS products, you've seen us talk about observability fabrics. This is, how do I get data out of that UCN into something that lets me do my operations thing with it, right? Let me run Wireshark, let me run Bro, let me load up ExtraHop and decode TLS 1.3 with secure export of session keys from host to it, so I can troubleshoot this traffic and administer and monitor my environment. That's the observability fabric. Today, we're narrowly homing in on the management fabric. Then the hopefully mostly out-of-band environment designed to enable connectivity between as many of my critical infrastructure systems as possible and enable policy-based segmentation of that infrastructure, of that management trust zone from the production network and from the observability fabric, allowing it to control those, but preferably have discrete points of controls put in place. I'm using the word control a lot, so that we can know what's going on in it and control access to it, know who can administer our network, and ensure that that's only the person who's supposed to, from the right place at the right time, doing the right thing with an audit log. A couple terms. Now, like we said, some of the most recent management network designs and architectures are as old as a college graduate in some cases. Unlike data center networks, where we've seen pattern-based deployments, there's a lot of snowflakes in this world, right? And I think we can have 5 different conversations with 5 very similar companies and find 5 completely different implementations and architectures that they're deploying. And that's okay right now. The data center looked the same 12 years ago when we started this journey around cloud networking. And we've seen a homogenization of design theory, increased opinions going into it, where the opinions were backed with principles that resulted in a smaller number of easily managed and easily scaled network designs that let us do a better job. Some of the common variables that you might find and will sway you different directions. Do I have rigid security requirements, specifically regulatory ones for administrative users and privileged access to the network, right? The scariest user in my network is me. Well, that's because they don't give me any access at all for good reason. The second most scariest user is like the tier 0 domain admin on Microsoft Active Directory, right? And controlling who uses that account and that credential and where they log in at. That login and access is a critical first step in who has access to manage switches and routers. And so we need to think of the entire trust chain in this environment, and how do we know who is who, and are they really who they say they are, and are they doing the right things? Back to John Kindervag's zero trust principle, applying as many of those processes and thoughts as possible and workshopping these architectures. And then also, in discussion of this with a lot of our senior systems engineering team, a lot of folks came back and go, but how do I do this in the campus? And my gosh, you're right. How do I build can I build? Is it even possible to build, depending on the distributed nature of my campus, a completely separate out of band management? It may not be, and that's okay. Each environment is unique. We're going to find different challenges there, and being able to work through those and say, I'm doing the best I can with the physical environment, the geographically distributed environment, the current state of some of the legacy infrastructure I might be having to incorporate. As long as you know your trade-offs, and frankly, and you document those, so whoever comes after you knows why you made those decisions, or whoever is the smart hands person who has to enact those controls and those implementations and those changes to stay coherent with your policies, you're okay. But yes, I've found branches. I don't know how to solve that yet, and that's an open conversation I would love to have with any of you. So Fred, walk us through a little bit of what we have here as we thought through a high level architecture, like the discrete segments or places we have to get administrative access to. How should I read this very pretty but icon-laden slide?
Yeah, so I think, I mean, if we kind of work our way from the left to the right, so the things on the left there are the end devices, right? The users, the IoT devices, whatever it is we're trying to keep connected, and how do we manage the network that connects those devices back to the internet or back to our HQ or whatever it is. And likely that's going to come across a WAN, right? Because this is back to the thing you were just talking about with campus and branch offices and things like that.
And WAN in this context might be two 100 gigabit Ethernet ports connecting my data center back to some large set of buildings I operate.
Right. It could be between, exactly, between campus buildings. It's not necessarily WAN in the traditional sense, meaning low speed circuits going out to places. It just means something that I'm accessing remotely somehow, right? And those got to feed back into this management network that we're talking about, that we have our users and our systems to administer these things. In addition, we have to factor in the multi-cloud there up on the top middle. How do we also manage and administer our resources in these clouds? A lot of these cloud providers actually have a lot of nice tools that allow you to access remotely managed, because that's by virtue of how they operate. They have these toolings built in to allow you to manage these things. But that being said, how does that tie back into the rest of the management frameworks that we have? How do we control access to those things with our admin users, leverage IAM profiles in AWS and similar mechanisms in the other clouds? And then closer to home, the data center, obviously that's going to be administered through this management fabric, and how the observability plugs in there as well. All these things kind of, you can see that they all have arrows moving to the right back into this management fabric. How does that single management network and management system control and administer all of these things, whether they be in the cloud, whether they be at a remote site, whether they be in my data center, or as you said, across 100 gig link to my other campus? How does that single management fabric and system administer all of these devices?
Now, Fred, I want to be clear. I put my team soapbox up, not for you, but for me. Okay. When you point to somebody like, 3 fingers are back at you, because what's about to happen. And when I look at this, I'll tell you what scares me, right? And Fred and I made this slide, and it's like, okay, this makes sense. This is a great logical way to think of it. That internet DMZ one scares me, and it scares me because this is a mistake we can make. I might have an edge router, and I need to have remote management of it. I need to connect it to I'll connect up to my management switch. I need to manage that remote firewall. I'll connect that to the management switch. That inside, the next hop switch, I'll connect that to my management switch. And what happens is the management fabric, improperly designed or without the appropriate controls and the appropriate thought on it, becomes the world's most perfect east-west lateral expansion avenue. Because if there's a well-known attack against a switch or router running at the edge, somebody gets on, and then they bypass the firewall by going to the management network, getting inside, and laterally expanding to anywhere they want across any of these assets. That's the risk factor if we do a bad job managing it and designing it. But now let's look at the other way. Go, if I don't have out-of-band management access to get to my internet edge, my DMZ architecture, if something's messed up there, my entire business is effectively offline from, if I'm like a post-digital transformation, company, how am I supposed to get to my clients? How are my clients supposed to get access to the critical systems of record that are often still resident inside of data centers that feed, systems of engagement that might be, geographically distributed and deployed across a combination of data centers and public cloud infrastructure? We have to get these two forces in balance, and proper architecture and design is the best way to do that. But that's the risk I want us to be aware of. Mistakes here can matter, and they could enable someone to do things we really don't want them doing on our infrastructure. So when you see we put local DNS over there, this is an example. Do I need all of my devices on the out-of-band management network to have access to a public DNS server or the normal DNS infrastructure in order to resolve a hostname and be able to go from one device to the next and resolve that hostname and get to the IP? That's acceptable for some folks, but I've seen other folks go, no, we need a dedicated DNS infrastructure to provide name service resolution that is localized, that doesn't leak these administrative and management names out into the rest of the world, and doesn't provide resolution services on that. So that's an example to consider. And we'll talk more about jump hosts, terminals, and so on inside this environment. So let's break it down a little bit more. Totally wordy slide. I'll get off my soapbox here. Less is more, okay? Balance and think through, what do you put on the management network and what don't you? I need to put all my IoT devices. I need all my badge readers. I need all my credit card PCI stuff. I need the more things you put on it, the more you expand the attack surface. I would strongly recommend, as a network or infrastructure professional, constrain this down to the things that are necessary, that if they go down, business continuity and operations are compromised. So this is my rationale for, candidly, how I get away from having to build this type of infrastructure for the campus. Because in many cases, access to the campus networks is reduced or compromised during the type of situations where we need to have our strongest dependency on these out-of-band and remote management infrastructures, okay? The main goal is to securely administer routine functions. Don't try to solve everything. What are the things that I need to do in a 1, 2, 3, 6 month window where I might have physical access reduced or compromised? Am I going to do a colossal network refresh and upgrade? Probably not. Am I going to have to upgrade software versions on critical infrastructure to mitigate known vulnerabilities? Yeah, I probably will. And so let's plan for the things we know we're going to have to do. And I would say, as a litmus test, can I roll out a software upgrade to my switches, routers, firewalls, load balancers, and other critical infrastructure components while being able to be remote and have the assurance that my workflows and my runbooks are well documented, my access to the systems allows me to maybe make a mistake and be able to roll back from that mistake and recover from it. And if I can do that, I've scoped it pretty well. If we try to boil the ocean again, we'll never get it done. So clear scoping, clear docs and runbooks. In many cases, I might be the knowledge expert, but I can't get there. And there might be somebody who's able to get to that facility, a remote smart hands worker. The better I dock it up, the more clearly I've established process and procedure, the more I've exercised those when time allows, the better served I am when I have to put those processes into practice. Okay, so things to think through. So Fred, we have a picture of a server and some clouds. What is this? I'm going to get off my soapbox now and go back to my backyard.
Yeah, your backyard's awesome, by the way. So
thank you.
Really, yeah. But anyway,
it doesn't look like this anymore. It's brown and greening now. So.
So you know, kind of taking let's instead of taking just a network centric view, we can look at the server and move out as to how do we manage from a server out. How do we manage things with the management fabric, the data center network? How do they all plug and play into what my servers do? And so here you can see we've got our data center, our data plane coming out of the server into the standard data center network, your leaf spine, which also plugs into your observability fabric. So there's your TAPAG and your monitoring. But then you can see out of band here, we have the management fabric. So that's your IPMI, ILO, depending on what vendor you're using for your servers. This is how traditionally you get out of band access to your management or to your server's management interfaces, and how you could administer these without necessarily having to SSH over your data center, your data plane connection, right? So this is giving you an out of band way of administering that endpoint.
So what speed do I need to, is this 100, 1000? What am I looking at now? What's the state of the art on ILOs, LOM ports, and so on? What's the current state of play there?
Yeah, I'd say 100, 1000 is probably appropriate.
Okay.
Typically, I think most servers are going to have gig NICs these days. Yeah. But you know, you could get away with 100 in some cases.
And I know I've certainly seen some devices that like some older UPS systems that have a longer lifetime and longer threshold of serviceability. You know, definitely staying in that 100 meg range. And so, okay, that makes sense to me. And then let's expand this a bit and say, now let's put it into basically turn clouds to boxes. And we are looking at, you see a dual homed compute leaf, the observability fabric, management top of rack switch. We tried to put some design notes because I know like these slides have a tendency of getting reused. We're totally happy to share the source content on this with anybody who wants it to. Again, shoot either of us an email, we'll get it out to you. I did them in Google Slides, so super easy. And yeah, goal, clear separation of administration and production traffic is a goal as we start here. And we kept thinking about how to show this. I think that starting with a server out made a lot of sense because there are critical infrastructure servers that are going to be part of this management network. It may not be every server, okay? But it might be those that are critical to business operations and continuity. This, we also try to highlight things you really don't want to do. I've done this, okay? I've personally made this mistake and I didn't think it was a mistake at the time. I thought that's just fine. I would put 3 switches at the top of the rack. I'd go ahead and I'd run all the ILO and LOM ports to the management switch. I'd run the out-of-band Ethernets from the 2 top of racks into the management switch. And then I'd connect the management switch uplinks back into the 2 top of racks. And somehow I didn't see this as a problem. I was foolish or unaware, or just not thoughtful and mindful about this. That is a like one hop circular dependency. This is the spanning tree loop from hell that I just built in 2 boxes, right? Because, so wait, if my management switch is out, I can't talk to my compute leaves or anything to administer it. And if my compute leaf gets borked up, I can't access the management switch to actually unbork it.
Right. Yeah, I think that's
Don't
a great
do
analogy.
this.
Yeah. I mean, it's putting the dependency on each other so that, you know, if either one dies, you lose access to both.
Yeah, I mean, this is your worst codependent relationship you've ever had right here in a network diagram. Don't do it, okay? Like learn from this. That was fine in high school. We're not in high school anymore. Let's grow up.
Plus, it also pollutes the management network, right? Back to the earlier discussion about how do we keep that management traffic secure and isolated such that, you know, we can reduce the attack surface. This opens it right back up.
Even if everything is up and running okay, like, now I'm dealing with additional complexity. Oh, do I segment it with a VRF or a VXLAN? Oh, wait, does a DOS or DDoS attack have the ability to mitigate it? Oh, no, I need a special QoS setting for the management traffic to keep it. Dear God, complexity is our enemy, okay? Like, what did we learn with cloud networking principles? Keep it simple. The more we can go to repeatable design patterns that are simple and easy to understand, the more the bulk of us in our industry can get on the bandwagon, have a firm opinion about networks, and that opinion becomes the ability for us to then take those opinions and turn them into infrastructure as code. Repeatable design patterns enable automation. Automation can reinforce that the repeatable design pattern is doing what it's supposed to be doing, right? Kind of basic systems control theory, what are the things that will bork a network up? Let's test for those. Let's ensure that we're not shutting down the uplink ports, and so on and so forth. So the more we put all these eggs in the one basket here, the more we make our lives harder, the more we add incremental complexity to the design to perpetuate a bad design that I could probably fix with like a pair of fiber, and I get 24 in a strand, I get 24 in a casing anyway. Like, we shouldn't do this, okay? Like, avoid at all costs unless you just can't.
Right, and to that earlier point, that management TOR is just a 100/1000 switch, right? So it's not like you have to put some super high performance switch in there. You just need basic, Ethernet access. You don't need anything fancy.
And now, 37 minutes into a presentation, it's time for a commercial interlude. Arista Networks is a proud sponsor of this webinar and provides multiple devices that might fit these icons in. And we're not going to make this a commercial webinar. And if anything is interesting here, please talk to somebody on the sales and transactional side, the SEs, whatever. We'd like to keep this above that fray, but yeah, we provide a lot of boxes that do this stuff. And we can go there if we have to someday. This is a little bit better model. Okay, now we're taking the host out, connects to a management TOR. That next hop back to the discrete management fabric might be some long haul fibers inside my data center, might be even connecting a couple discrete buildings in a metro environment together using some excess pair, excess lambdas. Those are reasonable options to keep it as discrete as possible within, again, a rational geographic distribution. If we start going really long haul WAN, yes, we're going to, like we showed in that first high level diagram, we're going to consolidate the management traffic over the production traffic at a certain point. That will happen. But, I think the right place to do that, if I have to, is connecting a discrete management fabric aggregation point to my UCN spine. And the reason I think that's correct, if I have to do it, is that we try to, in a layer 3 spine design, always use 4 boxes, or at a baseline. We can use 2, but I really like 4. And I like 4 because I can do change control in a box. I can have a box brick itself for whatever reason, and I still have 50% capacity left. So in a very rational, I'm making a change and there's an external failure case, I still have availability, I still have an N+1 architecture, like at least 1+1 in a dual failure mode, it's still working. And so the likelihood of me totally bricking the spine in a way that I've locked the management fabric out, I can't access it, is a managed, well-mitigated risk. I think it's an acceptable risk if I have to take it within an enterprise. So that's the point I would do that integration if I have to. Thoughts, Fred? Is that?
Yeah, I think that we have to be pragmatic about it too, right? There's a level of pragmatism here. But I think the key piece here is if you do make these compromises, and you made this point earlier, document them so that people down the line understand why you made that design decision. I think that's the key. It's fine to do things, just make sure you've laid out a rational reason why.
Yeah, that makes perfect sense. Yeah, thank you. Is that a compliment?
Absolutely.
Did I just hear a compliment?
Absolutely.
Oh, it must be bonus time or something. So let's flip the bit a little bit, because things change sometimes when it's not a server. What if the server becomes a switch? What if this is leaf 1 in that UCN leaf that's now connecting to the management TOR? What I would throw out here is, yes, that's what we're designing for. But think through the scenario where if I built this network right, I can turn off in-band management access, and I can reduce the attack surface of that leaf switch and those spine switches. I should not be able, done right, to SSH to loop back 0 and get to it. I could do that at nothing. There's no access. Let's shrink the attack surface of these devices in the production transport network to enable all administrative access and management access to be happening over the management fabric. That's the fundamental shift that happens here. Is too often we want to make our jobs easier and make our lives easier. So we compromise rational best practices, and we go, oh, I'll just SSH in from my desk. I'll leave a loop back on for myself so I can do my job better. Or we've put in place management tools that candidly are somewhat poorly designed, that aren't designed to work over the out-of-band management network. And I would struggle with that. Like, that doesn't make sense to me. So we need to, think through and make sure we understand our tools, understand the tools that comprise our tool chains, understand their requirements and dependencies, and guide towards this type of architecture as much as we can.
Yeah, I mean, I think we've all done using the switch as the jump box to get to the rest of the network, right?
Totally.
You SSH into the first switch, and then from that switch, you just hop along, to the next IP address, to the next IP address, to the next IP address. Yeah, totally.
Guilty as charged.
Done it a million times, but it's not the right thing to do. But it's just be aware of it.
And let's be clear. Like, if I've got my lab, I'm playing in my lab, knock yourself out, man.
Right.
Have fun. I don't care. Production operations for the type of customers who are on this video, who a lot of them consume a lot of Arista to build those highly reliable production environments, that's what we're talking about. Okay, like in those environments, we have to mitigate a lot of external risks that our organizations face, as well as the internal fat finger risk, and now the compounding issues of I might not be able to get to my facility to affect that administrative change. I tripped over the power cord emergency change control therapeutic reboot. It's a lot harder to do unless you've wired up your RPPs and PDUs to this out-of-band management network. Okay, and then you might have a workaround in place. But cleaner model here: compute leaves connect to management TORs, host connect to management TORs, in-band access gets turned off. Now, I did put a note down here. Okay, speaking to the point we made earlier, it's scenario dependent. You may want to connect those management fabrics back into the UCN spine, and that might be okay. Document it, know why you're doing it, make your run books align to your policies, to your controls. It can be okay, but to be aware of. So this basically showing that right now you can see the spine, the compute leaf, and the critical hosts all having some level of access to the out-of-band management network in this scenario. But now let's talk about how do you access those. So Fred, should you be able to go to your desk and type telnet and get to a switch?
Wow, I don't remember the last time I used telnet. It's been a while, but yeah, I think the answer is a clear no.
It's off by default on our boxes for a reason. Let's be clear.
Right.
You actually have to turn it on to make that stupid of a mistake.
Right. Yeah, I mean, there's just really no good reason. I can't think of any reason why you would enable telnet access to your box and why you would use that as a way of managing.
It's April Fool's Day.
Yeah, it's just I can't justify this one. So yeah. It's completely insecure. It's a hacker's dream come true.
My daughters made me do it. Is that the appropriate response?
You really had a lot of fun with the Zoom backgrounds.
I'm having a lot of fun with the Zoom backgrounds, Fred. I'll just bring a picture of my dog in. There we go. That one's mine over here on the right. Don't do this. Don't telnet in. Okay, not good. But Fred, what if I, instead of telnet, say, what if I SSH'd in?
Getting better. At least you've got some encryption. You've got some auditing capabilities, right? So we're getting there, but it's still not the best, right? You're still leaving a fairly wide attack surface open if you're just opening up SSH from your laptop, or from any random device into those other managed devices, right? You're still opening up the management network to attack.
Yeah, our design notes are pretty explicit here. Okay. The issue in this scenario is not as much the sanctity of SSH. Do we trust SSH or not? Is it secure? Is it encrypted? Is it cryptographically sound? Let's just trust that. It's two factors. It's one, the broader attack surface that's available across the critical infrastructure that you need to manage. That's probably more than two factors. It's also the trust of the host. Okay. And you'll see this in the next slide, but the risk is that if somebody compromises the host, they would potentially then gain access to any stored or cached crypto keys, which could then be used on behalf of the admin to get to one of these devices. The number one initial insertion attack vector, according to the Verizon breach report, phishing attacks. If you're using your laptop to SSH at work or your desktop to the devices, and you're using the same logins and the same credentials that you use when you check email, that's the risk factor. We need to understand the risk, put policies in place and controls in place that then allow us to mitigate that risk and audit to ensure we're continuing to mitigate those risks. So
it's also difficult to grab those keys back if the employee, say, leaves the company, right? If you got these SSH keys on one of their home machines and those are enabled on every device, now if you need to revoke that key, you've got to go touch every device and wipe that key clean.
Yeah, there's a Kerberos type of attack called the golden ticket attack. And the idea is that with a ticket granting ticket and domain administrator access, I can generate a perfectly valid administrative credential with a time to live of a decade. And the mitigation procedure of that is called destroy your entire Active Directory domain and rebuild it from scratch. Like complete non-starter, right? For almost any enterprise we do business with, like, I got to do what? I talked to one bank, they're like, yeah, we got 300,000 users and 400,000 machine accounts and in our Active Directory, multi-forest, multi-tiered. And I'm going, yeah, you're never going to rebuild it. They're like, yeah, we can.
Yeah, it's completely impossible.
Yeah, you can hire, Microsoft Consulting and Accenture and, every other consultancy in the world, and you're still not getting it done in 2 years. Right. So it's so difficult, right? And that's the risk factors that we have to consider in this. Like those are very logical avenues of approach that a malefactor could take towards taking over and controlling our critical infrastructure, the network stuff that we want to protect. So being aware of it and then putting appropriate controls in place to mitigate that. So what are we talking about here? What do I need to do in practice? You see the cool network admin with a network around it. That's the administrator doing administrative things. Then you see probably the exact same person in the bottom in the campus network. That administrator checking his email, checking her email, doing work stuff, filing expense reports, which I still need to do, like 3 months late. So that management workstation has access to a management gateway or jump host or bastion host that has access in to the management network fabric. Now, if we start thinking through what this would mean, that my user credential that I use when I'm logged into that management workstation should be different than the credential I use in the campus network. It should probably not even have access to my email, to my expense reports, or to anything except to get in and do my administrative job. When I relinquish that account and I go to check my email, I might be on a different machine. I certainly need to be on a different account, preferably a different account on a different machine to prevent keylogger attacks and so on. So these all become considerations. So thinking through that workflow, then, the administrative user goes to the management gateway. Now we're going right to left. It was Hebrew time, and then we go to the management fabric, and then into our production universal cloud network, leaf spine architecture in the data center. Key shared services often residing, and the shared services being those that oftentimes have a dual-headed approach. I might need access to some of these specifically in that management network, and aggregating those resources that are critical infrastructure support shared services functions into a physical and sometimes logical set of segments within the network that I can then control access into makes my job of shrinking that attack surface so much easier, because I know where bad things might happen and I'm putting those into a place where I can monitor them and validate that the right thing's happening. Any thoughts here, Fred?
Yeah, I think I mean, one of the key pieces here is that those shared services are part of the critical management infrastructure, right? If you don't have access to a lot of those tools, you don't have access to the devices you're trying to manage. So keeping an eye on those and keeping those healthy and secure is pretty important. I think the other thing to keep in mind is the scoping question we brought up earlier. Scope is very important here because if I can scope down exactly what should be allowed and what should not be allowed in these kind of controlled environments, the shared services segment or the management fabric, I can then tighten down the access controls for them very, very finely versus what happens in the data plane of your compute nodes. You know, there's just a million things happening there. You can't have a solid idea. You can't have a perfect picture as to what that traffic pattern should look like. But you can do that here.
You raised a really good point. Like determinism is the friend of IDS, IPS, and heuristic modeling systems, right? So if I have very finite, discrete, deterministic traffic patterns, and candidly, there's nothing more deterministic than machine-to-machine communication. It is one of the most deterministic because it usually happens at a particular cadence over very well-known and well-understood ports and interfaces. Our ability to model the baseline traffic that happens across the management fabric is so much easier than the problem we face in any production application user environment. Like you have no idea what I'm going to pull up next. I hope. If you do, it's really concerned. But you know, like we know at which cadence badge readers call home. We know at which cadence HVAC sensors report out. We know at which cadence the open config over GNMI over gRPC state streaming happens back to CloudVision. So the insertion of an IDS system is IDS, IPS, UTM, insert the appropriate set of security controls that are valid and you're using in your environment. They can be very effective in this side. The other one I've seen in more regulated environments is even going so far as to put honeypot systems on there that are designed to exist and look like nice, juicy Active Directory targets or things. So that if there's any connection to that coming from anywhere, you've then pinpointed where a threat actor may be coming into your environment. So again, it's how do I get tripwires and signal and know what's happening to protect the critical asset. So what about CloudVision? Like at Arista, we talk about CloudVision a lot, super cool product, big fan. How does CloudVision work in an out-of-band network, out-of-band management environment, Fred?
Yeah, so I think one of the neat things with the streaming telemetry is that, it can stream that over the management interface. So when you have your management interface on your Arista switch, that can be the source of your streaming telemetry. And now the CloudVision becomes an ally in trying to monitor and manage and maintain things remotely. I don't necessarily have to SSH into every device now because I could just go to the CloudVision dashboard and get all of that stuff in a nice, clean fashion that doesn't require a million different logins to a million different devices.
So it can function almost like that, a jump host for API gateway calls inside this infrastructure I can now significantly reduce the number of devices that are authorized to talk directly to any of my critical infrastructure on the left. My hand's invisible. There we go. It's really hard for me when I can't see my hands. And I've been told I talk with them a lot. So but on the right, these are the whitelisted hosts that can connect to the services on the left. That allows me to, again, reduce that attack surface and have a finite set of traffic that is flowing through maybe out of an observability fabric into a set of IDS, IPS, and other threat detection and mitigation devices.
Yeah.
I like
and
that.
if you look at how you manage things in the public cloud, it's closer to this model, right? You get access to the dashboard in one of the clouds in Azure's dashboard, and you manage the devices through that. CloudVision can kind of be a pseudo way of doing something similar at the network level.
Kind of back to taking cloud principles and applying them to enterprise networks.
Yep.
I've heard that somewhere before. So now let's reduce down to practice a little bit more. What does the actual traffic flow look like in a scenario here? And then what type of defense and depth controls could I apply? So Fred, can you talk us through the top and then I'll go through the controls?
Sure. Yeah. So, I mean, at the end of the day, just to make sure we level set, this jump host or bastion host, as some folks like to call it, is that point that you log into to then gain access to the devices under the management fabric, right? And so because it becomes that single point, you're then able to nicely control what's going in and what's going out. So you can have a nice list of devices that should be allowed to be authorized to access this host, as well as what devices this host should be allowed to access. You mentioned earlier about the Active Directory stuff and having specific accounts here. It becomes a great place to enable things like multi-factor authentication. I've even seen some cool instances where people make these ephemeral, right? So they time bound these and make these something you have to request access to. It will spin up a container that's your jump host for the duration of your maintenance window or whatever it is you're trying to do. And then when you're done, it goes away. So that no longer becomes a threat vector later on. So a lot of cool things you can do here once you adopt this idea of logging in through a intermediate device to get to the devices you want to manage.
And as the, let me put my InfoSec hat. I wish I should have another hat here I could put on and go, no, this is my InfoSec hat. It has horns, right? But when I put the InfoSec hat on, I can say, okay, well, now what are the defense in-depth controls that I apply to mitigate key terrain against this avenue of access into my environment? I'm falling back into Army terms again. It was ACOCA. That was the acronym we always use: observability, cover and concealment, key terrain, avenues of approach. I can whitelist the administrative workstations. The user account for the jump host is not used anywhere else in my domain. 2FA, MFA for access to that jump host. By the way, CyberArk bought a company called Conjur that made a very good jump host. I've used in the past. Solid product, liked it. That jump host has full command config logging when you're SSH'd in. You could use, like Fred said, I could spin up an Nginx instance, which is functioning as a dedicated API gateway if I need one, or CloudVision can function in that world as well, that translation API gateway there. I can use IDS IPS or other behavioral analysis tools for heuristic security monitoring of traffic happening across the management fabric. And then, as Fred mentioned, I can use tools like HashiCorp's Vault and so on for managing these secrets, these passwords and so on. So that's a non-canonical partial list of the controls. But if I took that list of controls and applied them across this effectively what looks like a kill chain, I'm reducing the attack surface. I'm putting rational controls at each hop, and I'm setting myself up to have tripwires to know if something's happening that is going outside of the authorized avenues of access. And that gives me as a networking professional a lot more confidence that I am reducing that attack surface and I'm improving the overall reliability and the security posture of the infrastructure I'm responsible for maintaining, and ensuring that nobody else is maintaining it for me. So on our previous session, we talked about config backup. One of the more useful automation functions to put into the management fabric is that config backup to a break glass server. Store those configurations. So if you had to go back and for some reason dynamically rebuild an infrastructure, you had a hopefully canonical list of all of the configs you've had deployed over time, and you can roll that back. Port beaconing to help smart hands folks, zero-touch provisioning and coordinated upgrade workflows that buy that risk down of executing a remote software upgrade, which I may be required to do to mitigate a vulnerability or exploit during a window where I may not be allowed to have physical access. That is like risk on top of risk. And that's what we have to aim towards. I can automate key rotations. And Fred brought up a great one, which is ephemeral jump host. What a great concept. I can spin it up when I'm logging in, and it can be torn down and destroyed after writing its audit log out to a Kafka message bus or something that goes to my Elk Stack or Splunk or management network SIEM. All of those become capabilities that we can use to improve the automation to reduce the risk in that management environment. So let's recap back and take what we've talked about and think through tying that back to those architectural principles. Everything's been about reliability. We've talked a lot about security to buy down enterprise risk to improve reliability. We didn't get a lot into scale, but as far as moving this architecture increasingly to repeatable patterns can allow us to improve the scale, the reliability, and enable automation inside this framework. Analogy I always loved. The best time to plant a tree was 20 years ago. So the second best time to plant one is today. I know we're all learning a lot of lessons right now about remote work, about remote administration, about maintaining your sanity while sitting at home. And sometimes having projects that we can think through. This is a potential timely project, right? It's the kind of thing that says, how could we get ahead of this? So in the life cycle of an asset we've deployed this year, we're going to see this type of challenge again. There's almost always, every few years, something that eliminates our ability to get to our networks. And if we get ahead of it, and we're able to have designs and policies and processes and architectures and training and staff and all that aligned, it becomes a non-issue. And that's the goal we have, to make network administration and operations fun, to make it amazing and cool, and to make changes non-threatening issues for people, whether that's through software quality, through orchestrated workflows, through telemetry to troubleshoot and improve visibility, to have observability on our networks to know what's actually going on and get packet level truth out of it, or to have remote administration and management capabilities that simplify our networks for our clients and allow them to have better operating experiences. That's our macro goal. Fred, any final closing thoughts from you?
I think you hit on a lot of the big topics there. One other thing, I'll just put that automation hat back on. You know, if you're looking for somewhere to incorporate automation, this could be a nice area. You know, it's a smaller surface area to implement automation, but still very high reward, right? I can make sure that I've got the right policies in place as I automate the control and configuration of the management network. So I think there's a lot of good things that can be done there from an automation perspective, for sure.
I'll put my automation background on for you.
Yes, very nice.
When in doubt, Google steampunk. All right. Well, everybody, thank you for spending some time with us, whether it was your morning or midday or afternoon, or if you're watching late in the evening. We really appreciate it. Again, if you go back to the first slide, you know, my email's up there, my Twitter's up there, so is Fred's. Reach out with any questions, any comments. If you're doing something here that's a little bit different and you just want a sounding board, that's cool. We love listening to that and learning. If there's something we didn't think of that you think would make a material difference to improving the way people design and build these types of operating infrastructures, I'd love to know it. Like we said, there's not a big corpus or body of information out there right now. And this might be the first time in 15 to 18 years it's been dusted off with any level of diligence on it. And we hope we can continue to improve these types of things and bring valuable content to you that hopefully that helps. And lastly, if there's anything we could do better, if there's anything you wish vendors would do that would make your life easier, I would love hearing that type of feedback as well. Don't be a stranger. Thank you for your time. And we look forward to connecting or staying in touch. Really appreciate it. And everybody stay safe. Thank you.
Thanks, everybody.